Facebook vanished for 6 hours in 2021. Not because servers crashed, because one system forgot how to find its own address. That system is DNS, the Internet's giant directory assistance. Every click, every login, every app depends on it. Today, you'll learn exactly how it turns Google.com into a real server, and why getting it wrong takes down billion-dollar companies. Computers don't understand Google.com. They only understand numbers, like 142.25.8046. Type a domain, and somewhere, something has to look up the real address. Servers move, IPs change, load balancers scale up and down daily. Without a system to bridge names to numbers, the internet breaks every time infrastructure shifts. Think of DNS like calling directory assistance. You don't memorize phone numbers, you say a name and an operator finds it. DNS works the same way. You type a name, a chain of operators hands back the real address. Understanding that chain is the key to nailing your next system design interview. This directory isn't small. Cloudflare's 1.1.1 resolver handles 1 trillion queries a day. VeriSigns.com servers alone process 170 billion lookups daily. Every single one resolves in milliseconds, invisible to you. This is the busiest lookup service on Earth, and it never closes. DNS isn't one server, it's a hierarchy, like an org chart. At the top, 13 root name server clusters. Below them, TLD servers for .com, .org, .io. Below that, authoritative servers owned by companies like GitHub or Netflix. Each layer only knows one thing: where to send you next. Those 13 root clusters aren't 13 machines. Each is hundreds of servers worldwide, using a trick called Anycast. One IP address broadcast from every continent. Your query always hits the nearest copy. Root servers don't know GitHub's IP. They just know, go ask.com next. Here's what nobody tells you. DNS doesn't just resolve addresses, it can erase a company from the internet. October 2021, Facebook engineers pushed a bad BGP update. It withdrew the routes to Facebook's own name servers. Every DNS query for Facebook.com timed out. Facebook, Instagram, WhatsApp, gone for 6 hours. So what happens when you type api.github.com? First, your browser checks its own cache. Miss. It asks your OS. Miss. The OS forwards the question to a recursive resolver, like Google's 8.88.8. That resolver becomes your personal detective, doing all the legwork on your behalf. Now the resolver goes to work. It asks a root server, who handles .com? Gets an answer. Asks the .com TLD server, who handles github.com? Gets another answer. Finally asks GitHub's authoritative server for the real IP. 3 hops, and the address comes back. This entire chain takes 50 to 200 milliseconds. But here's the trick. The resolver caches every answer. Ask again tomorrow, and it skips the whole hierarchy. Warm cache, 1 millisecond. That's a 200x speedup just from remembering the last answer. Not every DNS answer is a plain IP. A records map to IPv4 addresses. AAAA records map to IPv6. CNAME records point to another domain entirely. API.github.com actually points to github.map.fastly.net, which resolves again. Its aliases all the way down. There's more in the toolbox. MX records route your email to the right mail server. TXT records prove domain ownership. Google and AWS use these for verification. CAA records lock down which companies can issue certs for your domain. One name, many jobs. Every DNS record has an expiration timer called TTL, time to live, measured in seconds. When a resolver caches a record, it's valid only until the TTL runs out. Then it must ask again. TTL is the dial controlling how fast the internet learns about a change. Here's the trade-off every senior engineer knows. Low TTL 60 seconds means fast propagation but hammers name servers with queries. High TTL 24 hours means less load but a bad deployment stays broken globally for a full day. Pick your poison. Netflix doesn't guess, they plan. Before any major deployment, they drop TTL to 60 seconds. Deploy the change, confirm stability, then raise TTL back up. That 60-second window is also what powers their secret weapon: automatic failover. Route 53 runs health checks on Netflix's primary region every 10 seconds. Fail 3 checks in a row, and Route 53 automatically flips the DNS record to the backup region. With that 60-second TTL, users start hitting the healthy region within 1 minute. No human required. This isn't theoretical. During the 2021 AWS US East 1 outage, Netflix's Route 53 failover automatically shifted streaming traffic to EU West 1 and US West 2. Millions of users never noticed. Same DNS system that took Facebook down. Used correctly, it becomes your safety net. DNS isn't just about correctness, it's about speed. A user in Tokyo asks Cloudflare for www.example.com. Cloudflare checks the source IP, sees Asia, and returns the Tokyo Edge server's IP instead of one in Virginia. Same domain, different answer, based on where you're standing. This is how Cloudflare answers 1 trillion queries a day. 300 plus points of presence worldwide, each running identical resolver software. A cache hit never leaves the local POP. Only a miss triggers a fresh lookup, and even that happens from the nearest possible location. The result? Cloudflare's median DNS response, 11 milliseconds. Google's 8.8888, 72 milliseconds. OpenDNS, 55 milliseconds. Same job, wildly different speeds because POP count and placement decide how far your question has to travel before someone answers. DNS also load balances traffic without a single load balancer. Round robin returns multiple IPs in rotation. Geo-routing sends Europe to European servers. Latency-based routing measures real response times and picks the fastest path automatically. Same technology, 4 different strategies. But standard DNS has a dark secret. It's completely unencrypted and unauthenticated. Anyone on your network path can see which sites you visit, or worse, inject a fake answer. This attack has a name: DNS cache poisoning. For 2 decades, there was no real fix. DNSSEC fixes this with digital signatures. Every DNS record gets cryptographically signed. Each signature is verified using the parent zone's public key, chained back to the root. Fake responses fail verification instantly. .gov and bank domains now mandate it. DNSSEC stops fake answers, but not eavesdropping. That's where DNS over HTTPS comes in. It wraps your query inside encrypted HTTPS traffic. Chrome and Firefox now send DOH queries by default to trusted resolvers, bypassing your ISP entirely. Privacy upgraded. In your next system design interview, say exactly this. DNS is a hierarchical cache lookup system. TTL controls the trade-off between propagation speed and server load. That single sentence signals you actually understand the system, not just memorize the acronym. Remember the directory assistants? Root servers are the national operator. TLD servers are regional operators. Authoritative servers are the local branch with your exact number. Your recursive resolver? That's the assistant making every call for you and remembering the answer next time. That directory assistance analogy is why the internet scales to billions of devices without collapsing. Every name, cached, hierarchical, resolvable in milliseconds. Next time DNS breaks, you'll know exactly which operator dropped the call. Subscribe for the next deep dive. How CDNs cache the entire internet.